Hello, this is Fojtik demonstrating the data analysis using GraphDB and OpenStreetMap data sets. The goal of this project is to provide an overview of the Tinkerpop Gremlin API using Janus Graph as the underlying graph database. Project demonstrates the installation, configuration, and technology stack, as well as building a geospatial graph, particularly in Java. Java is the programming language. Graph database and graph computational concepts and overview. Essentially, the basic concept of a graph model is analogous to an object model. The graph contains connected entities, which are referred as nodes. The nodes contain attributes, key value pairs, which provide additional descriptions of filter criteria. Those nodes provide labels, which declare their roles within the graph, either as a vertex or a node or an edge. As well as they have relationships. Relationships provide directional connections between each node. The graph database uses the following structures. Nodes, again, represent entities such as people, business, or other items to be tracked. The edges represent the relationships between those nodes. And the properties represent information that relate to those nodes. The technology stack that I've selected is Janus Graph, primarily for the abstraction layer. As we build very large-scale applications, it's important that we have the routing logic or the graph modeling logic, as well as the graph computation logic, not specific to any one vendor or solution set API. So with Gremlin, it provides an abstraction layer for that logic. And then we can change out the back end as the needs of the scale become more apparent. So particular for Janus Graph, you have a storage back end. We can go with Cassandra or HBase or other technologies that may come online. And then for indexing, for quick index search, we have Elasticsearch and Solr and Lucene. The other important piece here is actually Gremlin connects to some other big data platforms, HDFS, Spark. These are newer technologies for that platform. However, they show a promise in the future. You can imagine we have graph computations on large clusters when you're dealing with the global geospatial information, as well as you can imagine connected vehicle data within that space. So technology stack considerations. Really, this stack takes a model-driven architecture approach where you have different architecture patterns in each layer of the stack. Okay, here's an architectural overview. Again, the primary tenet of going with that is an abstraction. The Gremlin server is what we communicate and program to. So the applications program to the Gremlin server and Gremlin API, which is an abstraction over the core API. This core API would be Janus Graph, Titan, or any other graph, Giraffe Graph, any other graph provider. And then underneath you have the graph database and then the graph processor. And the really important piece here is that this allows us to experiment on different implementations. So from the implementation piece, we can change out the back end when scale is required, and we can grow into particular implementation if required, and we can feel more confident in graph technology choices as advances in the state offer different providers for Tinkerpop. Okay, so we're going to get into some installation and configuration. So first of all, you download the binaries, copy the files to the Linux directory. In this case, I have both. For this demonstration, I will run on my Windows machine. I do, however, have a Linux installation here, but for the demonstration, it's easier for Windows. And there's primarily a few configuration files that you have to take care of. One is declaring the storage backend and the index backend, as well as then setting up the Gremlin servers. So we'll go into those particular files. So here I'm in the Janus Graph 0.1 Hadoop directory. It's important to note there is not a current production release of Janus Graph. As you see in my summation at the end, the conclusions, it actually caused quite some difficulties for my project, as this code is heavily in development daily. have many different conversations with the committers and developers of this product. They've moved from TinkerPop 1 to TinkerPop 3. TinkerPop 3 is a ground up rewrite. Therefore, many different bugs and challenges that caused quite some headaches. So again, standard structure, the bin, a binary where we do our startups, scripts, configuration is where we're going to spend a lot of our time. It comes with quite a few configuration files or property files already pre-built. Cassandra embedded with Elasticsearch. Cassandra backend is a clustered Cassandra service. So for my experimentations, I was using the Cassandra embedded with Elasticsearch just for ease of installation. And the size of my cluster at my house, and then Berkeley JE, so Berkeley database as well. The Gremlin server, this is an important part. Since we are using Gremlin remote, we need to configure our Gremlin server YAML, yet another markup language. And the primary pieces of concern as we go through this presentation are the local host. I'm running everything local. If I was to run this service on a different node, I would need to add my comma delimited list of servers. The port is 8182. And then the graph configuration. So this configuration file is the Gremlin server itself, which then connects and communicates to the Janus backend. So this is the binding file for Janus backend. And as you can see, we're going to start it up using Janus Graph Berkeley as a storage. And then some other important things are the serializers. We serialize SERDs, so serialization, deserialization. We're going to use the gyro message serializer. It currently has the most effective as well as least buggy implementations. The GraphSan is quite buggy at this point in time in their development. Some other information down here. As you tune these header size, chunk sizes for information flowing across the network. For right now, we will leave those alone, but know that you can configure these as you need to from a scale perspective. Okay. The next one is we're going to go look into this Berkeley server properties file. It's pretty straightforward. What we have right here is the bindings for Janus Graph Core, Janus Graph Factory. Again, as you can replace the backend, the graph database with many other providers for Gremlin server, this would be different if you were to have a different backend graph database. So we're going to use the Janus Graph Factory for instantiation of our graph objects. And then for the storage backend, we're going to use Berkeley, and then we're telling the system to store it in DB Berkeley, okay, which is right here, DB. There's the Berkeley database. Let's go ahead and start this up. We're going to go in and start up the Gremlin server. Okay, some important pieces to look for are, did we pull in our proper configuration files? Okay, yes we did. And then we've got 8182 running here. A quick run, we're going to start up a Gremlin console. Okay, TinkerPop server. Alrighty, we're good to go. We've been able to connect to that. Okay. So we've gone quite a bit through this presentation. So again, as you go through the start the Gremlin server, you want to look for these key items. We have the Gremlin server YAML, as well as then we have the Janus Graph Berkeley server property. So we know we are started properly. Okay, we've gone through that. The next is we don't want to. The Gremlin console is great for doing ad hoc queries, testing, and so forth. But typically, you would want to write a larger scale application that maybe has your specific logic. You can import and export files and so forth. Okay, I've got a project here. Typical startup of any Java is a new Java project. You want to create, for my project, we've created two classes. I have an app, which is your runner, And then services, the service would be our Janus Graph or TinkerPop helper. Okay. And then with anything in Java or programming, you need to reference the jar files. So we're going to go ahead and right-click properties, and we're going to include all the necessary jar files that we would need for TinkerPop as well as Janus Graph. Some important elements here. Let's go into the service. So as we create the service, this was the tricky part. Going from TinkerPop 1 to TinkerPop 3, they've changed the implementation drastically, a complete change. So documentation is pretty limited. But what you want to do is you want to, just as we had the YAML file for the Gremlin server, we're going to go ahead and instantiate an object called cluster, which is of TinkerPop. And we're going to pull in the configuration file, the config file here. We're gonna say, let's go look at the driver settings YAML. That's right here. Again, localhost, and then the serializer. What serializer are we going to use? Okay, so we're going to use the local host, and we're going to connect it to 8182, and do all of our Gremlin console submissions via that cluster, and we're going to bind a client to that, and the client is what we actually interact with. So the client uses the cluster instance to submit to Gremlin server. Slightly clunky. What you're actually sending is a text to Gremlin server. What they're working on is a better implementation where you can actually have IDE auto completion of the objects. But right now, for this project, as you can see, I'm wrapping. This is the Gremlin terminology. I'm wrapping Gremlin commands into a submit. Not the best. So if I wanted to add a vertex, so with my graph object, add a vertex of type name, and here's some names that we're going to add. Okay. As we go into our application, I've created a couple things. One is a method to delete the graph contents. As we're testing here, we want to delete stuff. Another one is let's import, right? So we have a Berkeley database as the back end, but it may be starting off as when you start off, it may have no data in it. So you may want to pull in a graph JSON file as well as a graph ML file, which is a more standard version to start off. All right, so we're going to go ahead and load some sample data. Let's see what we get. We should be able to connect here. I'm going to delete this. Go ahead and run this. Okay, we've connected. Okay, there we go. So now we've connected to our Gremlin server. You can see I've been doing some. It still has some statistics here. It tells me statistics of the standard meanings of the last iterations of execution times. And then what I got here on the console is I've loaded the sample, and then right after that I've actually run this get vertex property. So let's introspect the data in the database by running some Gremlin commands here, and I ran with this graph, give me the vertex that have a name, and just put that into a list. And then back here, I'm just for the list return, iterate what we have out. So it's very, very primitive. Okay. I've got another project here where we're going to go ahead and pull in a GraphML. The GraphML is of Albany, New York, which has our geospatial data. We're going to just list out, the same application would happen here. For this, we're just going to read it into an in-memory instance for the demonstration. And we're going to go ahead and load this in, get all the vertices, and then show them. Okay, let's run this as well. Okay, so in this GraphML, we have 40,000, about 41,000 vertices, 29,810 edges. So these are these are streets, so junctions, and then roads. So this is junction road junction mapping. And we went ahead and issued a command here. It says that for the label 18. Just find it. Nothing very special here, but I wanted to show that we can, from a graph, we can pull out a street. Okay, so really quickly, I'm going to show a graph of that. We're going to pull this into Gephi. So I'm going to load my Albany, New York. Here's what it looks like with that many edges, and we've got. I would show this as a non-overlap, but right now it would take longer than the 15 minutes to render. But this is showing the data here. So we're going to go to the data laboratory actually, so we can see it in a much more manageable notion. Our GraphML has IDs. These are the junction IDs. So again, I'm in nodes, which are my junctions, so road junctions, edges. Excuse me, these are the junctions of a road. The edges are the road connections. So my nodes have latitude and longitude. They have an OSM ID for OpenStreetMaps. I can reach out and grab more data about those. So again, and then we'll go into the edges. The edges have a source to target. This is my mapping from junctions to edges, and you can see they're directed. And then weights. The weights, unfortunately, are all 1.0. The weights that we would need would be distance. So if we have a distance in here, we can run an algorithm to determine the fastest path. Okay, well that's my 15 minutes, a little bit over. I thank you for the time. It was very quick to this. This is a very detailed and long project. Thank you.